Hello, this is Mrs. Short, and I'm going to go over adding and subtracting rational expressions here with you. I have about 4 problems to do. So the biggest thing with adding and subtracting rational expressions is you have to have a common denominator when you add and subtract fractions. And so when these things say simplify, it means they want you to put them together in one fraction. So when I look at this first problem right here, I see a 6 in the denominator and a 3x squared in the denominator. So if my denominator is one of them is 6 and the other one is 3x squared, I say to myself, well, I need something that they can match at. So basically I can grow 3 into 6 by multiplying by 2, right? So I'm going to multiply this one by 2, and then I have to do the same to the numerator. Well, then I know then the 6's will match. So now I notice that then the 6 over on the first fraction needs to get an x squared. So I'm going to give him an x squared. Ooh, that's a big... Okay, hang on a second. So I'm going to give him an x squared. All right, so now if I put these together, or if I write them both as their own fraction, I will have 6x squared for the first guy, and the top will turn into 5x times x squared, so that would be 5x to the third, plus, now this will be 6x squared, and the numerator will be 14. Well, if I put those together, that's 5x to the third plus 14 all over 6x squared. And there you go. All right, with the second problem, I have to subtract these fractions. Now these denominators, x minus 5 and x plus 2, there's nothing to do to make them look alike. You cannot add and subtract to make things look alike in the denominators. You can only multiply or divide. So what I'm going to be doing is I'm going to be giving each fraction each other in a way. All right, so I'm going to give this guy, multiply him by an x minus 5. So in turn I have to multiply the numerator by x minus 5. Well, on the other fraction, I'm going to have to give him a x plus 2. So I'm going to put it over here, x plus 2, and then it's like I'm giving the x minus 5 and x plus 2. All right, so my combined fraction is this. In the denominator, I have x minus 5 and x plus 2. In the numerator, I have 2x multiplied by x plus 2, and then I have minus 3 times x minus 5. All right, so I multiply that out. So the numerator becomes 2x squared plus 4x. And remember, there's no cancellation here. I don't want to cancel things back to the way it was. Then I distribute negative 3x and then plus 15. All right, and the denominator just sits there. You don't have to multiply it out. Usually you would rather leave it factored. All right, so this becomes 2x squared. 4x minus 3x is 1x, and then plus 15 over x minus 5 and x plus 2. Now, usually you're done, but you want to go ahead and make sure that 2x squared plus x plus 15, maybe it factors. So let's see, 2x squared plus x plus 15. So let's try and factor that. So I have 2x and x, maybe 5 and 3. So I don't think this is going to work. You know, everything in this problem is positive. And so no matter what I put in the back, it's going to, like if I put a 5 here or a 3 there, I'm getting 10x and 3x. If everything's positive, it's going to be much bigger than 1. Even if I switch it, nothing's going to work out to be factored here. But if it did, if the numerator here factored, and then one of the things in the denominator matched, you know, I would cancel those out. But it doesn't. So every once in a while, you got to worry about that. All right, this last problem over here on the right. You know, you have to factor any denominators that you see. For instance, this part, you have x plus 4 and x minus 4, it factors into. So when I factor it, I notice that it already has an x plus 4 and an x minus 4. So basically, all I have to do to get a common denominator is I have to give this other fraction an x minus 4, which means I give the numerator an x minus 4. Okay? All right. So the numerator becomes 5 plus 2 and then x minus 4 over x plus 4 and x minus 4. All right, so we got 5 plus 2x minus 8 in the numerator, and x plus 4 and x minus 4. So in the numerator, I get 2x minus 3. In the denominator, I have my x plus 4 and my x minus 4. Sorry, that's a little squished there. All right, x plus 4 and x minus 4. All right, so let's do one last problem here. All right, so if we look at all these denominators, luckily this guy right here is already factored, so I don't have to do that myself. So when I look around, I say to myself, well, this first fraction does not have an x minus 1, so I'm going to give it an x minus 1. And in turn, I give this an x minus 1 as well. And the second fraction does not have an x plus 1, so I'll give him an x plus 1. And this guy x plus 1. So now all my denominators match. So I have x plus 1 and x minus 1. So the numerator becomes 3 and x minus 1 plus x and x plus 1. And the 4 doesn't do a thing, so minus 4. So I'm going to go work that over here on the side. So I get 3x minus 3. Oopsie. And then this distributes, so I get plus x squared plus x, and then minus 4. So I clean that up, I get x squared plus 4x minus 7. All right, and so that's going to be the numerator, x squared plus 4x minus 7 over x plus 1 and x minus 1. Now if I think about 7, the only thing that multiplies to 7 is 7 and 1, so I can't factor this problem, so I'm finished. The only thing I would check is if the top ended up factoring and canceling with something on the bottom, but it does not. And that is it. Bye-bye.